So we discussed how basic indexing works in Pandas. There are other methods that you can use in Pandas that are more convenient when it comes to indexing and slicing a data frame. So for example, there is the .iloc method, which refers to the integer location. So the indices in this case, so the format is the following. So you type in the data frame, right? So this is the data frame, df, and then you type in .iloc. That's the iloc method, and then you type in square brackets, and then you type in integers for the row index and the column index. And let's see what that means. So we were working with this data frame, right? So this is again the row indices, these are the column indices, and there's the data frame is 3 by 3. Now how do we use integers? So again, Pandas or Python indexing is the same throughout. The way indexing works in Python is consistent. So the iloc method follows Python's convention of using 0 for the first index of the row or column. So when you type in so now you can see that let's say you want the 0th row, right? So for the 0th row, the columns have values 63, 75, and 88, right? So if you type in 0, just 0, this is going to be the 0th row, and it's going to assume that you want all the columns. So it's going to give you all the columns of row 0. Again, this is row 0, right? And so you get all the columns of row 0. And so this is the same as typing in comma and then colon. Colon again in Python means everything, right? So these two are the same. I've just typed them in to illustrate that they're the same. So if you type in the colon, it means you want all the columns, right? All columns. Okay. Now, if you want a specific element, let's say that you want element number, so let's say you want row 0 and column 2, let's say. So that you can type in, so this is going to be the row index, right? And this is the column index. So that's 88, so row 0. So row 0 is this, and then 2, column 2, so this is again 0, column 1, column 2, column number 2, so that's going to give you that. And this is again the 0th row. So you're looking at this element, indices of this element are 0, comma 2. And so when you type that in, you get 88. And if you, let's say, want 0th row and all the elements after 1, so it's obviously just one more element. So you can use that column notation that we've seen before. So again, so you type in 1. So this is row 0 again, and then column 1, and then onwards. With a column, you mean that you want everything after 1, 1 and after everything after that. so this is what you get, 75 and 88, which is this. Okay. Now let's see other examples of so let's say you want all the rows. So this means all the rows, and then column 0 and 1. So this means that you want the first 2 columns, and then you want all the rows. So you have all the rows of the first 2 columns. Okay, so we'll look at the iloc method more later on when we look at other data frames. So this is just a quick illustration into what's coming. Again, I want you to type in this code for the worksheet and submit it. So let's continue. Let's look at another method. There's another method which is just a .loc method in Pandas. So again, the format is that you type in the data frame name, and then you type in the .loc, and then you get the row indexer over here. So this can be the row label or row index, right? But this case, right, this one has to be the column name. So there's a restriction over here, so that this has to be the column name. It cannot be an integer. So this cannot be an integer. So make sure that this part, when you're using the LOC method, you use the column names in the position of in the second position. So let's illustrate this method. So we are again working with that quiz data frame. So df is again our data frame. You type in .loc, and then you type in the name of the index. So this is the row index, right? So now you can see that instead of taking numbers, you can now type in the index name. So you want, let's say, it's to see the score of John. So it can be more intuitive because you can use the labels instead of numbers. So you want the score of John for quiz 1, and so you type in the row, and then you type in the column that you want, and so that is 63. Let's see where that, yeah, so John has a score of 63. And so you can continue on. You can, so when you want more, when you want to, let's say, have more over here and more, let's say, rows over here and more columns over here, then you need to add in these square brackets. So please make note of that. It's important to remember that whenever you want to add more, you need to add include it as a list. And so this means that you want the scores of John and Ali, and you want quiz 1 and quiz 3. So you get that sub data frame. Now I'm going to post another video in which we'll illustrate how to get a dictionary using the zip method. It's very useful when you create dictionaries. So again, Pandas data frame function takes in a dictionary, right? And so you need to be good with how with dictionaries for data frames. So let's say that you want to add a new student in this case. Right? Now, how do we do that? So now the way this works is that you need to first create the same data frame, right, with that new student. So you need to create another data frame with that with the same format and with that new student in that frame. So this is our new student, and you'll see how this works. It's basically this is the list of all the column names, right? Column names are quiz 1, quiz 2, quiz 3, and these are the scores of the new student. So these are two lists that you're zipping together and creating a dictionary. Now once you have that dictionary, you give it the index name. So the index is going to be the row index, right? And so and the new student's name is Laura, and so you have her scores over here, and these are the scores. This is where you entered the scores. Okay, so once you have this data frame, now you can append this new data frame to the old data frame. So the way you can do it is by using the append function. So you do df.append, and then this is the new data frame, and so you get this student added to the data frame. You can it's easier to add a new column. So let's say you have another quiz and you want to add the scores of the quiz, the new quiz. You can just type in df, and then under in the square brackets you can type in the new column that you want to add under quotes, and then you can type in the scores, the new scores that you have. Now you can print it out. You can see that this is the new column that has been added to the data frame. So now it's not only numbers that you can do. Panda is a very powerful package. So you can basically also add, let's say, an average. So let's say you want to add the average of all these quizzes. That you can do by using the .mean function. And so in this case, what you're doing is, again, you type in a data frame, you type in the name of the new column in square brackets, and then you say that what are the values of this new column. You can use the .mean. But now this axis parameter is very important in Pandas, NumPy. It's everywhere. You'll see it. So axis just refers to either a column or row. In this case, 1 refers to a row, and so you're basically you're basically finding the average of all of these numbers, right? And then this is being included as a new column, right? And so it does it for all of the rows. Okay, so you can also delete. So let's say you don't want the average column, so you can just delete that column by using the del function, and then you just need to type in the name of the data frame and the name of the column in square brackets, and so you can see that the data frame has been removed. This column, this whole column has been removed over here. Okay. Now let's do one more thing. So when you're dealing with data frames, or you get a new data set, it's very common, and this is going to happen almost every time, unless it's it's a toy data frame, some particular toy data frames. There's always going to be these NaN values, which are values that are not defined, they're not numbers, so it's missing data basically. And so how do you handle missing data? So let's say that you have, again, so we're going to create another student, right? We're going to append another student to our data frame. And so so we again use that dictionary function and then zip. Again, I'm going to upload a video where which will illustrate how to use the zip function. But again, this is the name. These are the names of the columns, list of names of the columns, and then these are the scores. So this student does not have scores for quiz 1 and quiz 2. So these are NaN values. And so we create this data frame with the index, and the student's name is Donald. And so when you have the data frame ready, this new data frame that you want to add, or the new student's data that you want to add to your original data frame, you can again use the append function. And so how do you deal with these NaN values? We'll talk a lot about NaN values. But one thing that I want to illustrate over here is that, so let's say you want to calculate the mean or average of the columns of the scores of each student, right? So now you can again use that same method, but now if you don't use this, Pandas is going to complain. So you need to tell it to skip the non-assigned values, or the NA values, or the missing data. So it's still gonna, you see that you still get an average over here, but it's ignoring these NaN values, so you need to specify this. Okay, but again, we'll come back to missing values. It's a very important topic later on. Now you can also see one last thing for the first intro to Pandas is that you can also see the data types. So if you type in df, so this is again our data frame, and then this is d types mean data types. So when you type in that, it's going to give you the data type of each column, and so it's a float or real number, each of these. But you can also convert the data type. So let's say you want to convert the column quiz 4 to an integer. You can type in .as type and then int under quotes in parentheses, and so you can see that for that particular column, all of the numbers have been converted into integers.